The topic which we are discussing today is reciprocating air compressor. So these are the contents which comes under reciprocating air compressor. Here we are first discussing about the working of a reciprocating air compressor. Then we will derive an equation for the work done for a reciprocating air compressor without clearance volume and with clearance volume. And we will explain the working of two-stage reciprocating air compressor, and we derive an equation for how to calculate the minimum work for a two-stage reciprocating air compressor with perfect intercooling, and finally we derive an equation how to calculate the volumetric efficiency of a reciprocating air compressor. So these are the topics which commonly which are important as compared to reciprocating air compressor. Now, an air compressor is nothing but it's a mechanical device which is used to increase the pressure of atmospheric air. Normally, an air compressor sucks atmospheric air from the atmosphere during the suction stroke, and finally during the combustion stroke it is compressed to a very high temperature and pressure. That is, during the suction stroke it sucks atmospheric air from the atmosphere, and during the combustion stroke it is compressed to a very high temperature and pressure. So two strokes are performing in reciprocating air compressor or in a compressor: suction stroke and combustion stroke. And this high pressure, high temperature, as a result of combustion the temperature also increases. This high pressure, high temperature air is then drawn into or stored in a storage tank. From the storage tank, it is carried to different application with the help of pipelines. This is how an air compressor normally works. Since it is used to increase the pressure of air, what's the function of pump? You all know about the pump is a device which is used to increase the pressure of liquids, right? So since air compressor is used to increase the pressure of air, we call an air compressor as an air pump. So these are some of the applications where we find compressed air. So as you all know, compressed air is required in IC engines, compressed air required in gas turbine, jet engines, pneumatic drills, blast furnace, paint spraying, etc., etc. So these are some of the applications which we are using compressed air. So compressors are mainly classified into two types, that is reciprocating compressor and rotary compressor. Here I made a mistake, it is not type of reciprocating compressor, type of compressor. So sorry for that. Compressors are classified into two types, reciprocating and rotary. If the compression of air takes place due to the reciprocating action of a component, then that type of compressor we call it as reciprocating compressor. And if the compression takes place due to rotatory motion, we call it as rotary compressor. So rotary compressor has two subdivisions: centrifugal compressor and axial flow compressors. These two compressors we will study in the upcoming videos. In this video, we are concentrating only on reciprocating air compressor. So reciprocating air compressor is nothing but the compression takes place due to the reciprocating, that is linear motion. Now, this shows the working of a reciprocating air compressor. Before that, just understand that compressor is a power absorbing device. Compressor is a power absorbing device, because to initiate its operation we require a prime mover. The prime mover which is commonly used is nothing but the motor. So the main parts of the reciprocating compressor are suction valve, discharge valve, cylinder, piston, connecting rod, crankshaft. Once again, suction valve, discharge valve, cylinder, piston, connecting rod and crankshaft. The crankshaft is connected to the prime mover, that is the motor. When the motor rotates, the crankshaft rotates. The function of connecting rod is to convert this rotatory motion into the reciprocating motion of the piston. You can see here. The crankshaft rotates, the connecting rod converts this rotatory motion into linear motion. So during the suction stroke, the piston is at top dead center initially. and the piston start moving from top dead center to bottom dead center. So when the piston during its motion from top dead center to bottom dead center, the suction valve get opened. We can see it in this figure. So as a result, the atmospheric air is drawn into the cylinder during the suction stop. And when the piston reaches the bottom dead center, it completes the suction stop. Then the piston will start moving from bottom dead center to top dead center. That stop we call it as combustion stop. So during the combustion stop, piston moves from bottom dead center to top dead center. You can see during this stop, both the inlet valve and discharge valve are closed. So what happens is that the air which is drawn into the compressor is trapped inside the cylinder. Since it is both these valves are closed, so the air is trapped inside the cylinder and the piston is moving from bottom dead center to top dead center. So as a result, the combustion of this trapped air takes place. That is, the pressure and temperature of the trapped air increases. And when the piston towards the end of this combustion stop, the discharge valve gets opened. You can see in the figure, and we are getting high pressure, high temperature air from here. So these are the two strokes of reciprocating air compressor, single acting air compressor. So during the suction stroke, the piston moves from top dead center to bottom dead center. During this time, the suction valve gets open and some air is drawn into the cylinder. And during the combustion stroke, both these valves are closed, so the air is trapped inside the cylinder, and as a result, when the piston, since the piston is moving upwards, the trapped air gets compressed, and finally the discharge valve gets opened, and we are getting high pressure, high temperature air at the end. Now, this shows a detailed view of the various parts of the reciprocating compressor. You can see the inlet valve gets opened and the air is getting inside during suction stroke because the piston is moving from top dead center to bottom dead center. This is the piston, this is the connecting rod, this is the crank, and this is the crankshaft. The discharge valve remains closed during this time, and during the upward stroke, the discharge valve gets opened and we are getting high pressure air from the delivery valve. And from the delivery valve, it enters into the storage tank. From the storage tank, it is transferred by pipeline to various applications. So this is how a reciprocating air compressor works. Simple. Now, this shows the PV diagram. In PV diagram, the pressure is plotted along y-axis. Volume is plotted along x-axis, and the pressure is plotted along y-axis. 4:1 represents suction, because what happened during the suction, the air is getting inside the cylinder. That means the volume is increasing. So during this stroke, the air is drawn into the cylinder at inlet pressure P1. So during suction stroke, the pressure constant, volume increases. And 1 to 2 represents compression stroke. Compression. So as you all know, during the compression, what happens is that the volume decreases and the pressure increases. You can see from the PV diagram. So 1 to 2 represents the compression curve. And 2 to 3 represents the delivery, because you can see that 2 to 3 delivery means what? The air is drawn out from the compressor. So the volume decreases. So here 4 to 1 represents suction stroke, 1 to 2 represents combustion stroke, and 2 to 3 represents delivery stroke. The inlet pressure is P1 and the outlet pressure is P2. So this is the case of PV diagram for a reciprocating air compressor without clearance volume. Till now, we are not discussing anything about clearance volume. First, initially we will study about the working of a reciprocating air compressor without clearance volume. So this PV diagram represents the reciprocating air compressor without clearance volume. Now, in short, the main difference between a reciprocating air compressor and rotary compressor, we can say that the pressure produced in reciprocating air compressor is more as compared to rotary compressor. And moreover, the output from the reciprocating air compressor is pulsating. It is not continuous. whereas in centrifugal and axial flow compressor we are getting a continuous supply. So we can say that when we for applications which requires medium pressure and continuous supply, we are using centrifugal and axial flow compressor. For applications which require medium pressure and continuous supply, we are using centrifugal compressor. For applications which require high pressure, we are using reciprocating air compressor. So this is the main difference between reciprocating air compressor and a rotary compressor. So here, the combustion can be carried out in three ways. It can be carried out isothermally, it can be carried out polytropically, it can be carried out adiabatically. So this curve A, B, the black curve represents isothermal compression, the red curve A, B represents polytropic, and the yellow curve A, B double dash represents adiabatic curve. So this is the PV diagram for the compression which takes place isotropically, polytropically and adiabatically. So the important topics which comes under reciprocating compressor is we have to calculate the work done without clearance volume and the work done with clearance volume. So initially we are discussing about the work done for a reciprocating compressor without clearance volume. For deriving the equation for work done for a reciprocating compressor without clearance volume, we require some basic thermodynamic equations. We need to understand some basics of thermodynamics, because in all the cases, in all the textbooks we can see that they are deriving the expression for work done by taking the PV diagram, and because the area under PV diagram represents work, so by taking the PV diagram they are calculating the work. But here we are deriving the expression for work done with the help of thermodynamic relations. Since this is comes under the reciprocating air compressor comes under the application of thermodynamics. So we need to understand some basics of thermodynamics for calculating the work done for a reciprocating air compressor. Now, the first thing which you need to understand from thermodynamics is steady flow. So what do you mean by steady flow? Steady flow is nothing but the properties of the fluid does not change with respect to time. The properties of the fluid does not change with respect to time. That means the energy entering and the mass entering a device must be equal to the energy leaving and the mass leaving from the system. The energy entering and the mass entering a system must be equal to the energy leaving and the mass leaving from a system. In other way, we can say that there is no accumulation or collection of energy as well as mass inside the steady flow device. There is no accumulation or collection of mass inside the steady flow device. In other way also we can say that both law of conservation of energy and law of conservation of mass, both law of conservation of energy and law of conservation of mass are followed or obeyed in a steady flow device. So we can say that since the energy and mass entering and leaving and there is no accumulation of mass inside the system, we can say that the properties of the fluid will not change with respect to time. Why we need to study steady flow device means steady compressor is an example of steady flow device. So we need to understand what is steady flow. Then only we can clearly understand compressor, because compressor is an example of steady flow device. So you heard about the famous relationship, the steady flow energy equation. So HI, VI, ZI represents the enthalpy, velocity and datum head at inlet. HF, VF and ZF represents the enthalpy, velocity and potential head, that is height, at outlet. And Q represents the rate of heat transfer. We can write Q as dQ also. And dW represents the rate of shaft work. You can represent Wx as dWx. So enthalpy, velocity, potential head, rate of heat transfer at inlet. Enthalpy, velocity, potential head, rate of shaft work at outlet. This is known as steady flow energy equation. Why we need steady flow energy equation? The main reason is that steady flow energy equation is the basic energy equation for a compressible fluid. Because here we are studying about air compressor. Air is a compressible fluid. So the basic energy equation for a compressible fluid is air. If it is water, then we go for Bernoulli's equation. Because Bernoulli's equation is the basic energy equation for incompressible fluid. Since we are dealing with air compressor, we have to consider the equation for compressible fluid, that is the steady flow energy equation. So why we need to understand this basic concept of thermodynamics is clear, because compressor is a steady flow device. So we need to understand what do you mean by steady flow. Steady flow is nothing but properties of the fluid does not change with respect to time. That is, energy and mass are conserved. This is equation for calculating the steady flow. Why we need steady flow equation? Because air is a compressible fluid and this is used for a compressible fluid. So now here this represents a compressor and this represents the energy entering the enthalpy of entering fluid, and HF represents the enthalpy of leaving fluid, and dQ represents the rate of heat transfer into the compressor, and dWx represents the rate of work, shaft work from the compressor. In compressor, the magnitude of this V1 kinetic and potential energy are negligible. The magnitude of kinetic energy and potential are negligible in case of compressor. So when you neglect these two terms, so you are left with HI, Q, HF, dW. So if the kinetic energy and potential energy are neglected, then we have an equation HI plus dQ is equal to HF plus dW. Here Q can represent as dQ because the rate of heat and the rate of shaft. When we bring HI to other side, we are left with equation dQ is equal to HF minus HI plus dWx. This HF minus HI, we call it as delta H, that is change in enthalpy. So now I derive an equation for a compressor in case of by applying steady flow energy equation. Now I derive an equation for compressor by applying steady flow energy equation. Now from first law of thermodynamics, we get an equation dQ is equal to du plus dW. You all know first law is commonly applied for closed system. There are two systems, right? Closed system, open system. Closed system is nothing but there is no transfer of mass. But in open system, there is transfer of mass as well as energy. In closed system, only energy transfer takes place. But in open system, both energy and mass takes place. Here, the compressor is an example of open system. Because here, compressor is an example of open system. Because air is entering and air is leaving. There is mass flow. That means it is an example for an open system. This equation is used only for closed system. So here dQ represents heat, dW represents work. So dQ and heat and work are the two forms of energy you studied in thermodynamics. What is the difference between heat and work? If the energy transfer takes place due to temperature difference, then that energy we call it as heat. If the energy transfer takes place due to reason other than temperature difference, that is it can be due to pressure difference or something like that, then that type of energy we call it as work. So energy are classified into energy. There are two forms of energy, heat and work. And all substances are made up of molecules. The energy of its molecules we call it as internal energy. So internal energy is defined as the sum of kinetic energy and potential energy of its molecules. So dQ is equal to du plus dW. This equation is obtained from the first law of thermodynamics. And dW is equal to PD. This work equation we can use only for closed system. Since our system is an open system, that is air comes an open system, we cannot use this equation. dW is equal to PD. And we have the Joule's law. This equation du is equal to Cv into dt. This equation comes from Joule's law, which states that internal energy is directly proportional to the temperature. Change in internal energy is directly proportional to the temperature difference. What do you mean by Cv? Cv means the specific heat at constant volume. Specific heat at constant volume. What do you mean by specific heat? I will first explain the definition. It is the amount of heat required to raise the temperature of unit mass of a substance through unit degree Celsius. It is the amount of heat required to raise the temperature of unit mass of a substance through unit degree Celsius. Let's say you take 1 kilogram of water. Its temperature is 27 degrees Celsius. You heat that water, 1 kilogram of water, which is at 27 degrees Celsius, to 28 degrees Celsius. So, the amount of heat added during this time, that is to raise from 27 to 28 degrees Celsius, that heat we call it as specific heat. And if this heating is done at constant pressure, we call it as specific heat at constant pressure. And if that heat is if the heating is done at constant volume, then that heat we call it as specific heat at constant volume. So if the heating is done at constant pressure, it is specific heat at constant pressure. If the heating is done at constant volume, it is specific heat at constant volume. So that is du is equal to Cv into dt, where Cv represents the specific heat at constant volume. So these are the equations which we need to understand from the first law of thermodynamics, which is required in our further studies of compressor. Then from the second law of thermodynamics, we get one term, or we get one property, or we define one property called entropy. What is entropy? Entropy is a measure of degree of disorderness of a body. In short, we can say that entropy is nothing but it's a property which increases with addition of heat and decreases with rejection of heat. It's a property which increases with addition of heat and decreases with rejection of heat. So ds is equal to dq divided by T. It's a equation for calculating the entropy. Then here comes enthalpy. What do you mean by enthalpy? Enthalpy is nothing but the total heat. It is one of the common terms which is used in open system. Enthalpy plays the same significance as that of internal energy in closed system. That is, in open system, enthalpy plays the same role as that role performed by internal energy in closed system. So in other words, we can say that enthalpy is nothing but internal energy and pressure volume energy. This is known as flow energy. So open system only there is flow. So enthalpy is the term which is used in open system. Internal energy, sum of internal energy and pressure volume energy. So these are the basic equations which we need to study from thermodynamics. So far we have studied, we derive an equation by applying the different equation, we derive an equation for compressor. We just look into some of the basic equations of thermodynamics. Now, just you know about this formula, H is equal to U plus P. You just differentiate that formula. dH is equal to du plus apply product rule. First function into derivative of second function plus second function derivative of first function. So you have du plus PdV. So what is PdV for an open system? For a closed system, what is PdV? It is dW. So you can replace this PdV as dW. Then what is du plus dW? dQ, right? So you can replace this du plus dW as dQ. So bringing this to this side, we have dH is equal to dH minus VdP. So now from this basic property relationship, we derive an equation for heat, right? dQ is equal to dH minus VdP. So from the compressor steady different equation, you derive an equation for heat. With the help of property relationship, we will have equation for heat. So what is these two represents? This is for open system, this is for closed system. So what does this represents? This represents the same thing for work. So from this, comparing these two equations, we get a formula dWx is equal to minus VdP. So we can so from this equation we get Wx as minus integral Vd. So this is the formula which we are using for calculating the work for a reciprocating air compressor. Minus sign indicates that it is a power absorbing system, because we all know that when we apply work on a system, the work done is taken as negative. So the Wx is used, the minus sign indicates that that is the compressor is a power absorbing device. So the formula for calculating the work is Wx is equal to minus integral Vd. In the upcoming videos, we will be discussing how to get the equation for polytropic compression from this equation. Okay, so before that, I need to tell you one more thing. Yeah. What do you mean by polytropic process? What do you mean by isentropic process? What do you mean by isothermal process? You know about. You know that for an ideal gas, PV is equal to mRT, that is, if temperature remains constant, mass R, T are constant, so PV is equal to constant. This equation is applied for isothermal process, and PV raised to gamma is equal to constant. This is used for isentropic process. You know about isentropic from the previous slide. And polytropic means if the pressure and volume are changed according to a relationship, then that type of process we call it as a polytropic process. And during the polytropic process, this N represents the polytropic index and gamma represents the adiabatic index, and the value of N is less than 1.4, between 1 and 1.4. For air, the value of gamma is always 1.4, and we have to understand, you need to understand that AD under PV diagram represents work done. You all know about that. AD under PV diagram represents work done, and AD under TS diagram represents heat. AD under TS diagram represents heat. And Cp minus Cv is equal to R, and gamma is nothing but the ratio between Cp and Cv. Here R, it is not universal gas constant, it is characteristic gas constant. That is, for getting R, we need to divide universal gas constant by molecular weight. For getting R, you need to divide universal gas constant by molecular weight. This all you learn in your subject called thermodynamics. So we require these equations during our further study in the topic called reciprocating air compressor. Thank you.